Hello, everyone. I'm Rihanna Beg, Editor-in-Chief at Machine Design. For this Insights conversation, I've invited John Ellis, engineering entrepreneur, inventor, and founder of Massachusetts-based engineering consulting firm Optics for Hire to join me. It's a pleasure to meet you, John. Thank you for joining me.
Thank you. Pleasure to be here. Nice to meet you.
Your company provides contract optical systems design and prototyping. And from your LinkedIn profile, I learned that among the projects you've tackled include medical devices to image the eye and ear, optics used inside the Xbox Connect,
Mhm.
LiDAR lenses for the Google autonomous self-driving car, LED lights, semiconductor equipment, robotics, inspection, auto stereo 3D displays, spectrometers, night vision systems,
Mhm.
panoptic cameras, and there's so much more.
Mhm.
And all of this to say, uh, in fact, you said it, that your work can involve optics, mechanics, or electronics, but always somehow involves the emission or collection of photons. Now, somehow, this gives me the impression that this is your company's area of distinction. So, can you walk me through your elevator pitch on what your technical expertise extends to?
Yeah, my company is called Optics for Hire, and we've been around for about 20 years. And our employees are primarily physicists who are designing systems that, as you said, collect light or send light. And that could be anything from light emitting from a street light, which has to make a particular pattern on the ground to meet a transportation standard, or a camera that's looking at boxes moving on a conveyor belt and trying to read barcodes or dimensional information. But it's a lot of other things too, and there's a huge range of different kinds of products that you know um, are using light or sending light, and that can include a little optic that we helped Mattel design that went inside a Barbie doll, to $100,000 microscopes that the Argonne National Lab is using to look at scintillators. So it's just a very wide range of kinds of applications, but it's always sending light, which could be in any wavelength, or collecting light. So we're designing the lenses that collect that light or send that light, the mechanics that hold those lenses, and then electronics to process the light or move zoom motors or drive lasers. And it's a pretty diverse range of customers and applications.
It really is. I was fascinated to see how far-reaching this could be, and I'm excited about that. I'm really excited to talk to you to help us navigate some of the applications. So you are the inventor of the Roll Ranger. That was the world's first tape edge sensor that solves your everyday annoyance of losing the edge of the tape. I really could have used that at Christmas time. So tell us the backstory on this invention.
As I talked about, most of our work has been contract optical engineering. And in the last few years, we've gotten involved in starting to use some of our own technology, or technology that we were familiar with, to license or create commercial type products. And one of those products was a little toy that has spinning fan blades, that has animation on it. And our engineers figured out how to make the animation work based on the timing of the fan blade spinning, and each fan blade had a bunch of little LEDs. And you can see these at any kind of retail outlet, Walmart, Target, Walgreens. And our customer, who uses this technology, has then licensed it to Disney and Marvel and other companies, and put animation of the Frozen movies or Jurassic Park movies on it. So that was a little technology that we licensed, and sort of got a feeling for the potential of licensing, because that has sold many millions of units. From there, we started on a new project, which, being from Toronto, might be something that you're familiar with. My kids are all hockey players. They were quite young at this time, and I never quite knew whether their ice skates needed to be sharpened or not. Were the children falling because the ice skate wasn't sharp enough? Because your blade has to be very precise, can't have any nicks, has to be just sharp enough, or you're going to fall when you're ice skating. I thought about it a bit, and then I worked with my engineers, and we came up with a sensor that would use a camera to look at the edge of a hockey skate and determine whether that skate needed to be sharpened again. And we built that product and then sort of realized that the price that it was going to have to be manufactured at and the value that it added wasn't really big enough. So we sort of moved on to knives, and then we launched a product which has been sold by the Farberware brand that tells you the sharpness of your kitchen knife. So most people, when they're sharpening their knives at home, don't have any the feedback methods are all subjective. How well does it cut a tomato? Is it cutting paper easily or not easily? So we made a little optical system that you could insert into a knife sharpening system, electric or any kind of knife sharpener, that would then tell you, with a light, green is it's sharp, yellow it needs more sharpening, and red is dull and you need to sharpen it, give you that kind of feedback that was based, not on some subjective method, but actual, data about how light was scattering off the edge of it, which was an indication of the thickness of the blade, which then was an indication of the sharpness of the blade. So that was our second adventure. More recently, I was just being frustrated with, packing boxes and shipping things to customers, and annoyed that I, needed to use these things and I couldn't find the edge. And even with my glasses, I would, stare at the roll of tape and I would, feel around for it and I could never figure out where it was. And then even if I did eventually start to figure out where it was, I couldn't, I would tear, and when I was ripping it off the edge. And it was just annoying enough that we had a conversation with our team about, was there a way that you could optically sense the edge of a roll of tape, and you have to do it very inexpensively. So we came up with a system that actually doesn't really use optics at all. It's a lot more like actually a phonograph record with a little pin here that, if you can imagine an old phonograph record, the pin was going around and going up in those sort of pits and around the track to play the music. And this pin then, if you can see my demonstration here, as you move around the roll, when it gets to the edge, I don't know if you saw the light come on, the pin is sensing where that edge is and then triggering a light to come on. And then we have a scraper that you use to, lift up the edge and uniformly put pressure across it so that you can get going, because we all have a lot better things to do with our day than get frustrated with rolls of tape. So that was the most recent thing. And that one we've decided to launch ourselves. And that's the one called Roll Ranger. And it's for sale on Amazon and different other retail. So it's been a lot of fun to learn about, selling consumer products and getting the price point right and getting the packaging right and getting the marketing messages correct. But it's just another example of sort of using, technology that we have, or this is really precision mechanics. You have to know how to create a spring just the right way. You have to know about, manufacturing and injection molding to make a product work properly. So, the skills that we have from optical engineering are kind of applicable to lots of different kinds of things, that some are really important problems and some are not so much, not so important, but annoying enough to want to solve.
No, indeed, certain things that that we take for granted and that there are solutions for that you're providing.